So the all right, so we've got all these files over here for the most part. Okay. And this, when I write over here, when it says C drive /user/Andrew/desktop, and notice the backslash is there. That's the way Windows does paths. That's the path to a file. A file itself is generally just one string, is a single string. Like for here, automate the storing stuff with Python _new.pdf, right? Think java.pdf. The PDF is there as part of the user, is there for your sake, and so when you double click on it, you kind of have a default application that it opens up with. But honestly, if I didn't have this on there and take off the file name, right, I go with to open with, and I tell it to open with, let's see, the PDF file, the PDF thing. Sorry, my PDF reader. It opens it just fine. The file extensions, they are there for basically convenience. They aren't actually necessary. Okay. Now on a Unix-based system like Mac or like Mac or Linux, files that are organized, all your files in Windows essentially under the C drive for archaic reasons, and in Linux everything is underneath root, or on Unix as well. So here I can cd to root, and here I'm at the top of my directory. Let's go ahead and up the text size of this setting. Configure console. General. Or not. Control ++. There we go. That looks much better. Okay. So here I can and I can use the ls command to list everything in the directory I'm currently in. So here I'm at the top, bin for binary files, lib, mount for all those files that get loaded up on the screen. So a whole lot of files. Just checking to see if something was an artifact. Yeah, it is. Now, most of your files, if you're on Linux or on Unix, are in a home directory. So if you look under the home directory, right, there's Andrew, and then if you then under there, let's go ahead and create a file. Let's go ahead and make a file. I'm going to use the touch command to make a file, and you can actually do all these things in Mac with the Mac. So touch example.txt, and now if I list my files, I've got a example.txt file. And now if I go ahead and say cat example.txt, this will enter a bunch of text into there. Hello, this is an example file. How are you? I'm fine. And then I Control C to end that. And now if I use cat, I can actually print out that file. Cat's kind of a useful command like that. And so if I open it up in an actual editor, it would open that up. But here it says now here my home directory, like where I store my stuff in a Unix system, it has a shortcut key, whereas root is the /. Note that that's /. In Linux and Unix, so Macs as well, there's this the tilde key is used as kind of a shortcut for where your home location and where you log in by default. So if I go to cd documents, make dir examples. So this is just making a directory. Go into the examples folder. You notice that basically everything's separated in a Unix system with forward slashes. All right, so that's the primary difference. So if we're writing something in a so here's like an example of how stuff can be organized, right? You've got the path and then you've got the file name. Technically, everything in Linux is a file, including those folders. They're just simply ways of organizing things. So obviously we need to, so Windows uses the backslash, Linux uses /. Pain in the butt if to code for both. Fortunately, you don't have to worry about that because Python is fantastic. So for instance, and I'll show you this is why I have two things built, booted up. So here I'm going to boot up Python. So if I import the OS, this gives me a whole bunch of operating system commands. And now if I run the command os.path.join, it will help me like put together, like if I want to basically have a string that represents a particular path, like the examples folder, like the desktop folder, and then let's see, home and then documents, right? I can do this. I can do it like this. Let's see. Actually, let's go. So let's say I have let me make a CD desktop. Sorry, not desktop. Yeah, why not desktop? We're going to put this on the desktop since it's easy to see there. CD desktop. I'm going to make dir example. So created one. So I'm back in the home folder now. Python. So import OS. And now if I do os.path.join, I'll be able to put, and I do desktop, comma, example, those two strings together. It produces the double backslash for me because I'm operating in Windows, right? If on the other hand I go to Linux, and this is pretty cool, so again, I'm going to go cd ... to go back to the home folder. Okay, I'm in documents, actually make dir example, cd ... So now if I do Python, and here I have to do Python 3 to specify I want to use Python version 3, import os.path.join, and it's the same thing, desktop. Oh, I didn't do this there. I didn't do on my desktop. I did in documents, but documents. It gives me documents / example, 1 /, not 2 backslashes. So it's a way to so this is pretty good at being providing you interoperability. So wherever you are in Python, by the way, there is you're in a current working directory. In Linux, this is actually you can actually figure this out from a command just by doing pwd, print working directory. But basically, it's letting you know where you are in the file system, right? Because when you're running something, you are somewhere in the file system. You aren't just like in a nebulous amorphous space. You have to be somewhere because you have to be able to look for files. So we need a way again to be able to find that. So Python again, import. Oh, see. Actually, I can probably do away with that. So Python, right? And for the most part, right, we want to use the get cwd, get working directory. So import os.getCwd. So it says I'm in the users Andrew. which is where, if you're running the command line, you start by default, right? If I run an idle and I import OS and I do os.get cwd, I actually have no idea on where I'm going to end up with. I'm in users and Andrew app data local programs Python 36-32, which is where idle opens up by default. And this gives you, well, yeah, and so this gives you, so there's two things here to know about. This gives you what we call the absolute path. In other words, starting from the top of your file system and going all the way down to where you are, right? This also starts from the top of the file system and going all the way down. So that's your absolute path. That's how you find stuff. The other way to find stuff is a relative path, which is relative to where you currently are, right? So use the dot. So there's two like fake folders in every folder, okay? As far as the command line is concerned and Python is concerned. The first is dot, and the second is dot dot. Okay. Right, and if I actually do a list of all the files, ls-a al, if we scroll up among the files, it says like here's your desktop documents, downloads. At the top it says dot and dot dot, which are two fake folders essentially that are within every folder. And what they are is they are shortcuts to represent basically a relative location. Dot is where I currently am, and dot dot is the way to get to my parents directory. So, for instance, if I'm here, I'm in c:/user/Andrew, I go cd dot dot dot. I go cd dot dot. This brings me up a level. If I just do cd dot, it doesn't change anything because I'm telling it to go, you know, where I currently am, which doesn't do anything. Again, and I'm using PowerShell, which uses a bunch of the same commands that they mimic a lot of the same commands that Linux has. Typically, to list files, you have to use dir. I can use ls though, and it'll do the same thing. So cd Andrew, cd for change directory, and again, it lists everything that we've got here. All right. Here's an example folder. Like if this is the current working directory, c/bacon. The relative path for it is /. My parents' path, to get to my parents, which is the root directory, I have to go dot dot. The fizz folder inside of bacon, that's /fizz, which is c. So c, that's like current directory fizz. So if I wanted to run a file in here, right, Python hello.py, I can go /. So I'm saying this current folder, something inside this folder, hello.py. Unexpected end of file. Oh, do I have to do 2 slashes? No. Unexpected end of line. Well, it's just a problem with the Python file. So vim, apparently I don't have a working hello.py in here. That is the case. There we go. This folder, right? And inside this folder, hello.py. This folder, sorry, my parents folder, then once I'm inside my parents Andrew folder, hello.py. So I'm saying go up, go back down to where I am, right? So you can get insane stuff with relative paths, but what the entire idea of relative paths is not actually to do stuff like that. It's to make things easier by saying I don't have to know the absolute file system where I am. It's saying that basically, okay, I'm in this directory and I've installed this program, right? And we run Python from where we've installed this program. Then we know that this folder has the images, this folder has the text files, this folder has this. So, or if I'm in the images folder, if I go up one, I'm in my parents directory. So we can make also new folders. So you might want to try this one out and see what happens. Okay, because it might not work. So import. So here again, Python. We're going to go into Python. We're going to import ROS, right? And we'll do os.make deers. And I'm going to go and use this thing. Nice thing feature about the current version of Windows is I can copy paste into here. So C drive delicious walnut waffles, right? And now let's see what happened. So let me go into my C drive and I go to my OS and I've got a folder called delicious walnut and waffles. Pretty nice. So I can make folders basically at that top level. That's pretty cool. If I do that if I do that in here though, let's see what happens. So let's go ahead and again do console. Okay. Okay, so Python 3 import OS. OS dot, let's see, what was that command that I used? The make deers. So, this should start giving you the idea of that even though you might not be not ever want to be a person who uses command line, you totally could do everything you want in Python, right? It's a perfectly valid what's called scripting language for writing little things just to mess with files, right? And being able to, so let's go with /delicious and what was the string? Delicious walnut waffles. Traceback permission denied. Now this has to do with the fact that that I have no that as the user I have no permission to write in that directory. Similarly, if I was in the over here and I said instead to put this into let's say the Windows folder, right? Right? One of the things you should never do is like delete your Windows folder, right? Or modify it, because that's where all the Windows files are. It says permission denied. I can't mess with the Windows folder because I am a standard user, right? I have and this is why you can't like mess with some files on those computers in front of you, because you're just a standard user, you're not an admin. And you have to do admin privileges to do stuff like to be able to install stuff. Kinda. Depends on what you install, right? If you can just drop a file in and that's considered installing it, then you're good to go, which is why why Python is pretty wonderful like that. So I have to put this somewhere where I can. So I'm going to change the slash, which means root, to tilde, which means home. So inside my home folder, I'm going to put in delicious walnut waffles. And now if I go to the Dolphin file manager, which is so now I've got, the tilde, which doesn't need to actually be there. Apparently made a tilde folder. Oh, right, because there we go. And now I should have and now I'm going to be wondering like a year later why I have a delicious walnut waffles kind of deal. And what was I thinking? And was I really into waffles? So here I'm at my home again, and now I've got, delicious. Okay, so all I had to do for here is actually lead off all this stuff, and it assumes it wants to put it in my home folder. And there we go. So it assumes you want to be in your home folder by default.
Is that because you're
In my home, that's because where I currently am. Okay. So there's a whole lot of functions in os.path, which is like common file name manipulations, figuring out where the absolute path of your file is, the common path name, expand variables, get mtime, return the last time this path was modified, get the size of this path, right? So so let's see, os.get path get size, all one word, get size of let's go ahead and see, where are we? So we're in I'm in Andrew right now, so if I can go into desktop, and I will go with gh.py because that's a short name, and that should be 1 kilobyte. So desktop slash gh. Oh, and I have to use // here because remember I'm in this one. I'm in Windows. // gh.py. Says it's 13. That's the size of it. And if I had used the slash there instead, it would have given me an error, I'm sure. Oh, nope, because it's smart and it figured out, hey, you wanted your Windows, you should take that slash and convert it into //. So Python's very useful like that. All right. Is link, is amount. You can join things together, like we've seen, the relative path to get there. So it's all sorts of, so we've got all nice and useful stuff. So os.path, the absolute path, will return a string of the absolute paths to the argument. It's an easy way if you have a relative path to take it and convert it into the absolute path. So where I currently am with the relative directions to the top-down directions on how to get there. Calling path.isAbsolute path will return true if it's an absolute path or false if it's a relative. So here's an example. So os.path.absolute path. If I put in dot, I know exactly where I am right now. I'm in C users Andrew. If I ask for the absolute path of this folder, the documents example, it gives me that. It gives me the absolute path to that. So that's pretty nice. Yeah. So let's see. So let's see. So now we're going to, so we can look at the, so you can do common things that I've been doing in the command line here. You can get the size of something. You can also list everything in a directory. So let's go ahead and do something that might backfire on me and say, hey, let's go ahead and list dir all my documents, and it comes out with, and here we've got a list of all the files that are in my documents folder. Okay, so all right, so we can check a lot of stuff with the files. Now we're going to get into the files themselves, which we've been dealing with. So in actuality, there's only 2 types of files. There's plain text files, and there's binary files. All right, so let's go ahead. We're going to use their example of calculator.exe. So I'm going to use Vim for this because Vim is awesome and easy to do. So I'm going to go and cd ... So let's see. So where did it say is my calculator? It's in windows.system32.calculator. So I'm going to go into, again, that file that trolls on the internet will tell you to delete. So cd ... cd ... cd windows cd system ... system32. So inside here there's a whole bunch of other things, as you can see. Tons of files in here. Tons of them. Right? Don't need to list them all, even though I was totally doing that right then. Let's take a look at, now let's go ahead inside of a text editor, open up calculator.exe. This is the, so if I go type calc.exe, right, this is this program, the calculator program. So let's open it up and take a look inside of it. Okay. I thought I said to do that. Vim calc.exe. Ah, there we go. This program cannot be written in DOS mode. So we've got some text in here. Ooh. A lot of it's gibberish, though. Copyright the Microsoft Corporation from the shell calculator, dependent assembly.
What's the gibberish one?
This, it's compiled code, essentially. This is code that's been compiled into instructions that can run on your machine, right? So remember what the Python does, right? It's a program that, and this is easier to see with a compiled program. So I think what I'm going to do is I'm going to actually have to make it, show you guys on my virtual machine again over here. So I'm going to go ahead and, let's see. So let's go ahead and vim hello.c. So this is a program written in C. Now, let's see. How do I do it? I think it's include standardIO.h. I think I need string. Do I need strings here? I forget. For including for the hello world program in C. Int main. Yeah, it's standard IO. I just can't remember with the include what else I need. So printf hello.
You're writing in
Java. No, C. Looks a lot like Java, doesn't it? GC. Yeah, don't really need it though. Hello dot C. No standard IO.h. Oh. X. Oh, there we go. No quotation marks. So, okay. So, and now if so that compiled the program, and now if I do run /.a.out, it'll print out hello world. Notice that it didn't create a new line because I didn't tell it to do so. So this is the hello world in C. Let's take a look at it. So this is the C programming language. Python is written in the Python interpreter you use is written in C. It's fairly minimalistic, unlike Java, but it's not as minimal as Python. But that's fine. This is just simply to how minimal is it, right? You know the print line statement that we use so often doesn't even come as a regular feature. You have to include it in your program in order to use it, because you might not need to print something out in your C program. So this is just the standard library for doing input-output operations. Okay, and this is the header file which says let's load up all the actual code. Then it looks for the main function. This just simply says the main function should return an int, which we don't bother doing it because we don't have to. Printf, hello world, right? Remember the print. We didn't go over the printf command here, but it's a way to pretty print stuff. Print format, and I'll put in a new line there, and then I use a semicolon to end the line. Right, quit. So let's go ahead, and then what you do is I compile it. I'm using the program called GCC, the new C compiler. Don't really have to remember any of this stuff, but basically it's remember from the very first lecture I mentioned there's two types of programming languages really: interpreted and compiled. Interpreted means it goes line by line, right, and translates and takes a interpreter, right. And the interpreter translates it into commands that your computer can understand. The compiler just says, let me just take the entire program all at once and interpret it, and we're not going to bother interpreting it because the interpreter gives us some flexibility at the expense of speed, right? So, Python's a much lighter language with a lot more cool features as a result, but C is faster. But anyway, so now if we list, we have it compiles into hello.c compiles into a file called a.out, and now if we open it in vim a.out, right, this is the machine code that got generated. Yes.
So it's kind of like interpreters just get one piece of pizza at a time, and then compilers just take the whole box.
Yep, essentially, compilers take the whole box. So anyway, notice that there is some stuff in here that we do recognize. Oh, and I can look for hello world, and there's my hello world string right there, right? This is the part of the text that probably prints out the whole part of the code that prints out hello world. But it's not meant for us. This is a binary file. It's meant for the computer to read. Okay? And this is important. That what's meant for a computer to read and what's meant for us to read can actually kind of surprise you, right? For instance, cd users, Andrew, I don't have to do one directory at a time, desktop, right? Here I have all those files, right? Move think Java to think java.pdf. This is me putting the PDF extension back on the Java, think Java file, right? Think Java, or so anyway, but think Python. Let's go ahead and open that up. If I open up think Python, the PDF in here, it's also a bunch of gibberish. Nice blue on blue gibberish too, right? Yeah, think Java, think Python. It's not really going to make a difference. Think Python.pdf, color scheme equals, can we do desert? Default, whatever. Okay. Issue is I'm trying to half remember command. But anyway, this is not easy to read at all, if for no other reason than it's blue on blue, right? But as you can see, even though the PDF, you can read it inside of a program, that's the point. You can read it inside of a program. It's a file that's meant for a program to read. The file is meant for the program to read, and then you read it through the lens of the program. So it's a binary file. Basically, if I can open up in a text editor, it's a plain text file. If I can open it up in a text editor and I can't understand what the heck's going on, it's a binary file. Okay? So we're going to be learning how to deal. So first so that's why we're not immediately jumping into Excel, like how to manipulate Excel, because Excel spreadsheets are binary files. They're meant to be read through a program like Microsoft Excel or one of the free alternatives like LibreOffice. The flip side of this is that basically because they're so common, we'll learn that there's a library that basically allows us to manipulate it as though it were a plain text file. So we're going to be dealing with plain text files for the most part. That's why we'll be starting with, again, the CSV files, because I can open up a CSV file over here, right? But if I were to open this up in Excel, all right, and then save it, right? So save as, let's go ahead and save it as not open documents, but because we're going to actually use Excel, so where's that? Excel workbook at the very top, okay? So let's look at it as an actual Excel file that we would use. So now I'm going to open it with code because it is either binary, very large, or uses unsupported text encoding. So let's see, open with, choose another app, more apps. Do I have GVim? Yep, Vim. I'll use Vim here. So very tiny text. Oh, it can't unzip it. So it's just having some, whatever. So the point is that it doesn't want to read it. Okay, is the point. So whereas I could read the CSV version just fine. Okay. So now to open files, we've learned that we use the open command. Okay. And we've been learning actually how to do that in a variety of ways. So I'm going to go again, cd desktop. Actually, I'm going to stay here, over here, Python. Okay, so now I want to open up the book1.csv file that's in my other. So target file is equal to book, right? Is equal to open book1.csv. And then I'm going to say I want to read it in read mode first up. It says there's no book1.csv, and they're right, because where am I? import os os.get gets current working directory. I'm in this top level directory. So instead, I have to, so it's inside my desktop folder. So so I'll go desktop. So notice it's in my desktop folder, right? It's on my desktop. So desktop book1.csv r. And so now it's able to read it. Okay. So there's a couple different ways to read this file now that we actually have it. So notice what it is. If I type out type, which is the way I can tell what the type of something is, of target file. So notice that new command, type. It says it's a input-output wrapper for reading text, right? Just to make it clear, like if I put x and 5 and then I ask for the type of x, it tells me it's an integer, right? If I have a dictionary and I ask for what the type of the dictionary is, right? Big surprise what it's going to tell me. Type of D is a dictionary. It's dict, right? Right, so type is useful for basically saying, hey, if this is one thing, handle it this way. If it's another thing, handle it this way. Okay, so the first way is that I've shown you that I can basically do the 4-line in target file, right? Which is how I can read it line by line. But if I wanted to like read this and store it all in a string all at once, is equal to target file.read. And it'll go zoop, and there it is, all at once. It's all one string, by the way, which makes it a bit hard to manage, right? Here's all the comma separated values, and how do I know what is one line by another? Well, it's got the new line in there. See that /n over there?
So it reads left to right.
So it's all left to right. It's reading it all. Yeah, it's reading left to right, and then it hits the new line. Because really, what your files are, the way you can view these things, is that they're just one giant string. That's all files are. They're just giant strings. Right? If we open this again over here with code, right? It reads this file, and then it's got a new line. And the way it renders a new line, it doesn't go /n. It goes put a new line there, so it's easier to read, right? Same with a tab, right? It doesn't go /t. It actually prints out like a bunch of space. So that's one way to do it. That's sometimes inconvenient. You might imagine that that's actually very inconvenient. So another way I can do that is I can use lines, and then I can use read lines. Of course, it's empty because I've already read the file, right? Does that make... I'm already at the end of it. So I'm already at the end of it. So can't really do anything from there. So let's go ahead and... So the IO wrap. So what I've done is that I've basically created what Java says is an IO wrapper around the file using the open command. Using the open command like this says to Python, not Java. I'd really like to read this file. Right. I want to read desktop. What's in my desktop folder, books.csv. Right. And now I can use the lines is equal to, and basically this enables me to read it. But because of the way it works, I only go through it once. Basically one line at a time. Read lines. Target file. So now I've opened it up again, and now you can see that basically it includes the new line in it, but every time there's a new line, it puts a comma after it. So now I can go through and go 4-line in lines, print lines. Oh, no, I wanted 4-line in lines. I said for every time there's a line, print the entire thing. I just want to print the single line. So now it goes and prints out each line one at a time.
What was the difference between those two commands?
So read and what? The 2 for loops?
Mm-hmm.
I had print lines as the first one, which, right, for each line,
Container.
yeah, I said to print out the entire container as opposed to the individual thing I just took out the container. Easy to do when you use my strategy, which is to use pluralizations and singulars for your variables. All right, so that's reading, which we've learned. Now let's learn about something else that's pretty fun, which is writing files, right? Which also means that we actually have the means for writing our first basic computer viruses, or rather malware, because viruses imply that they go automatically. But if I can write stuff onto a computer, that means I can eat up your space, which means I can just dump a giant file on you, which all things consider not too malicious, but because you can easily delete it, but still mean, and you should never do that. Seriously, what? Seriously, don't do this unless it's on your own, literally your own machines, because there are because of the way a lot of. So first off, I don't know what Japanese laws are concerning cybercrime in Japan, but they generally seem to be very unforgiving. Like in the United States, right? In a lot of when you log into somebody else's Facebook account because you have their username and password and got it somehow, that's considered basically unlawful. That's an automatic felony right there, believe it or not, because you are using somebody else's data and credentials unauthorized. It's very it's just very broad. Now, mind you, again, you're safe if you tinker with your own stuff, and that's kind of the important thing. If you tinker with your own stuff, that's kind of fine. But really, what we can do is that we can start writing files. So let's learn how to write to files. So I'm here in my top level directory. So we're going to open up a file, and let's follow along with these commands. Okay, so you guys can follow along with me. Nothing malicious is going to happen here, because you're going to be able to see what's going on. And I just somehow lost my shell. Great. Or no, I lost my my Explorer. All right. So, that is so interesting. Oh, I see, because I've got, okay. Okay, so now let's go ahead and go to automate the boring stuff again. So let's go ahead and go through these commands over here. And then we're actually going to be able to work on our exercise for the day, which I'll make. But it's a fun little, we're going to actually be able to make literally a full-fledged game based on reading and writing files, which is pretty fun. So let's go ahead and look through this, because I want to make sure I get these right, and I like these examples. So bacon file is equal to open bacon.txt and with a W. Okay, so notice the W there. Python bacon file open bacon.txt W. So this creates a file. Now, by default, when you open a file, you open it with a read-only mode. Okay, so you can only, when you open files, you have the option of opening them with either a read mode or a write mode, essentially. There's a third mode, which I'm about to show you. Okay. But let's go ahead. But anyway, now that we've got this file, I can start manipulating it. Baconfile.write hello world. Baconfile.write. And then we can write to this file just like we're printing it to it. Hello, comma, world. Okay. And it says I wrote 13 bytes there. And now let's go ahead and do, how are you today? Not 13 bytes, but 13, let's see.
Oh, so each letter is a byte?
No, yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 18 there. Yep. So 18 there. So now let's go ahead and open up my file. Let's go to Andrew, right? Because I put it in this top level thing. And let's notice that I have a file that I created called bacon.txt, right? I didn't make it before. It's currently blank, right? Because it's actually waiting to write these things. Okay. Now to say that I'm done writing these, so it's basically holding these all in stasis for me. Now I say baconfile.close to close it up. And now I can open this up. There's 31 bytes in there. And it says, hello world, how are you today? Now it doesn't have a new line in it because I never told it to put in a new line, right? Unlike the print command, which automatically puts in new lines, write doesn't automatically put out new lines for you.
So it's just dot close?
Yep, dot close. Baconfile dot close. Now if I open this file, now here's the important thing. If I open this up again in write mode, okay, this means that I essentially assume that I want to write a, when I use write mode, it means I want to write a new file called bacon.txt. Notice that I didn't have a file called bacon.txt. So I want to write a new file called bacon.txt. So this will completely overwrite the old file. Baconfile.write pig /n. Okay, and now if I do baconfile.close, I'll close this up and I'll open up our bacon file. Notice that it's 11 bytes now. Open it up. It says pig oink. So whenever you use the write command, you are overwriting a file. Okay? So a lot of times you want to check if a file already exists. Right? Does that file already exist, which you can do with the path command.
Modify.
So there is a modify, which is using the A. Instead of using a W, we use an A, which stands for append. So there's essentially three ways to write a file. That we can interact with a file by opening it. Okay? We can read it, we can write it, and we can append to it. We can only do, and append just means add to the end. Now you can only do one thing at a time. Notice that he closes it and then opens it again to read it. Okay? If I want to replace a letter or something in there, yep, essentially read the whole thing, replace it, and hold back is the easiest way to do it, and that's actually part of what we're going to be doing with our assignments, with the assignment that I've got that I like for us today. Baconfile dot is equal to open, so now we're going to open bacon dot txt A. So now I'm adding to baconfile. Baconfile dot write, same command here. Bacon is not a vegetable. Bacon is not kosher. Okay. And so now we do close to say that we're done writing to it. And so now this will dump everything out. And so now if we look at bacon.text, it goes pig, oink, bacon is not a vegetable, bacon is not kosher. Not a kosher. Because I am a grammar. That's why. So now to read it, we would just read it the same way, which is to read it using we would open is equal to bacon bacon file is equal to open bacon.txt, and then if we don't put anything in there, it assumes it wants to read it by default. Okay, bacon file bacon text is equal to bacon file dot read, and now if we do and we can close, and then we can print out bacon text. Now, technically, what I should do at this point is that I should close the file, baconfile dot close. That way, if I have another process that wants to open it, to read it, or write to it, that you can't. Basically, opening it says I want to work with this. Close says I'm done working with it. Okay. So there's also another thing you can do over here, which I'll let you look out later, is that suppose you've got really big variables, you can save your variables to the disk. Right now we know how to write files. So instead of the idea here is that what we've learned is that instead of printing stuff, we can also write stuff to a file and tell them to look at the output that way. But you can also shelve Python, basically the entire chunks of your Python program or data in your Python program, so that you can load it up. Right, your variables normally die at the end of a Python program, but now since you can write to a file, you can shelve them. So, So now what was I saying that we can possibly use this maliciously, right? So I'll give you guys an example of how to do this maliciously. Okay, don't do this, but this is like basic. I'm trying to show you just that a lot of viruses and stuff are either malware, not viruses. This is realism. Unsophisticated, and B, sometimes a mistake. I've accidentally blown up a server, like metaphorically speaking. Like what I did is I accidentally set all the permissions that were necessary for the computer to run as basically that the person who was loading them up can't look at them anymore, so that prevented the computer from booting, which was really frustrating. I had no idea how to fix it. I think that what happened is that we ended up basically we grabbed all the data off there and basically reflashed it, essentially reset it. So one of the things you need to learn when you're working with computers is that you should not be that these things are essentially not disposable per se, right? Because they're expensive, right? But the software components, the parts with the ones and zeros, that's disposable. You should be prepared for basically data loss at any time, right? None of this, I lost my USB that has all of my documents on it, right? As a programmer, which is what you guys are now, or at the very least tinkerers, all right? Which we have another term for, hackers, right? You should be able to use something like GitHub, right, to store your files. Now owned by Microsoft, which if you need to, you can also run your own Git server at home. You've also got GitLab, right? Which is a competing thing. I also use Bitbucket because I like to keep so all the classroom stuff that I put on for you guys that I store for you guys, I put on GitHub. And all my classrooms, all the stuff that I'm writing for myself, like the assignments and the exams, I keep that on Bitbucket because that's a completely different site with completely different credentials, right? So there's a reason for that. And it's just a separation of services. It's also unnecessary on my end, but there's drive storages these days, right? If you guys you guys get pretty much unlimited cloud storage, yeah.
Why would you put it on like Bitbucket or GitHub when you could put it on like Google Drive?
An excellent question. So the different because Bitbucket and GitHub fulfill completely different purpose than Google Drive. Google Drive is the assumption on Google Drive is that if I store data there, it's not really going to change, right? For instance, I stored a bunch of the rips of the DVDs and Blu-rays that I have on my Google Drive so that I can access personal use. It's questionable at this day. Personal use. So, right, I've got DVDs and stuff that I've got here, and as long as I'm not sharing them, it's fine. Okay? But so that gets into piracy. At what point is something piracy, right? Well, no, seriously. Seriously, and it gets really complicated, and of course, I mean, you wouldn't download a card, would you? But those movie files don't change, is the point. Okay, these files do. The files on GitHub do change. So this is using something called version control, right? So let's go ahead and
incremental backups.
Yeah, that's essentially what this is. Incremental backups. So here's like an example of my thesis that I wrote, okay, which I used using LaTeX, but as you can see, there's also a lot of Python files in here that I used for plotting stuff, for my simulation, right? So here's a bunch of Python. It was ugly. It was a simulation I wrote myself. But anyway, let's see. So history. So let's see. Where's the history to this? History of this file. So as you can see, these were incremental changes over here that I was making. Yeah, so here's my simulation file, March 25th, and then comments like, I might need to get a linter. It's getting bigger, right? Here, I just created a node, a class. Then I created more classes to run it. And then basically what it's showing over here with the green are changes. Like I removed these lines, but I added these lines over here, right? So these were the changes over here that I made to these things. And right, so here's like the file I had before I made the change. And what the use of this is that basically is that as I commit things into this, I can, if I basically mess up, I can go back to an older version that I know was working. So it's very useful to make incremental changes. But even better is that like on open source projects, there's this feature here called pull requests, right? Which people can make, say, they can look at the idea here is that people, if it's open source, everybody can look at it. People can make a new pull request and say, hey, I noticed this was a bug. You should change this. And people will go, okay, we can change this, right? So people can, random people can essentially make suggestions to add. All right.
So, what's the difference with Bitbucket?
Bitbucket is just another service to use. They're all using Git. There's different types of services. So first off, there's different version control systems. There's SEM. Git is the one that's very, very popular because it sucks the least, according to Linus Torvalds. Or maybe not according to him, but he named it after himself.
Linus the Linux guy?
Yeah, Linus the Linux guy. He did. So let's see. So I think that gets us enough, though, to where we want to talk about our. We're actually going to use a problem from the book, a project from the book, because it actually looks like a lot of fun to me. And there's a couple. And so what I like about this is that the book is that it does have a lot of step-by-step projects. But here, this one I thought was really good. A good game that we all know or should know called Mad Libs, right? Everybody know Mad Libs, right? So we're going to create a Mad Lib program, and what it's going to do is it's going to read text files and let the users add their own text anywhere. Adjective, noun, verb, adverb. Sorry. Yeah, so adjective, noun, adverb, or verb appears in the text file. So an example, a text file might look like this. The adjective panda walked into the noun and then verb. A nearby noun was unaffected by these events, right? So the idea here is that the program will read the file anywhere it sees an adjective, like, so enter a silly chandelier screamed pickup truck, right? So, and then the following text file would then be created. The silly panda walked into the chandelier, then screamed. A nearby pickup truck was unaffected by these events, okay? And then we do, it's a very simple kind of assignment. The results should be printed to the screen, and then you save them to a new text file. So the idea here is that it will read a text file, right? A Madlib text file. And if you want, right, we'll just deal with one, but if you've got an entire directory full of Madlib text files, you can randomly choose a Madlib, right? And then it just parses, it goes through and goes, okay, well, that's not one of the words I need to look for. Adjective, that's one of the words I need to look for. So what you can do, right, is you can use the split command, right, to split up everything into word by word chunks, right? So that you can look for them. So that's, I think, is a pretty good way, because it will involve you working with, having to open a file, read the file, then write the file. Okay. But anyway, the last thing I wanted to do was to show you kind of how easy it is to kind of just create something malicious, right? Mentioned that. So new file, we're going to call this Andrew Classroom create 100 files dot py. And it's going to do exactly what it says on the tin, is that we're going to create 100 files, okay? So what we're going to do is that it's very simple. For I in range 0 through 100. Actually, let's go with 1 to 101. right? So all the numbers from 1 to 100. What we'll do is that we will target is equal to, so this will create 100 files, by the way. So just, and I'm going to delete them. I'm just going to run them wherever I'm going to put them in the current working directory, right? So target is equal to, I mean, I could. Target is equal to open. And so here, notice all the options over here. So notice that some of them have like mode equals this. So these are like default values here. And this, the file says is the one that you need, and then it says mode is equal to R. But if you, and that's the second one. So I can just simply put right there. Right. And we're going to call this one stri plus txt, or we can call it a haha file, right? This isn't really anything at all, but it's still like on the way there to show you that it's not that really hard at all, right? For blank in range 1 to, let's go with 1,000 of these, okay? Target dot write spam. So notice what I've done here is I'm creating a file and I'm writing spam into it on a bunch of times. Target dot close, right? So I'm gonna go and go to CD classroom. I'm gonna run this from where it actually is. CD ITP CD, and now create 100 files. Oh yeah, what did I forget? I forgot a quotation marks, right? I forgot to put quotation marks here around the haha. And the reason I'm doing it in here, by the way, is because otherwise it's gonna be hard for me to find them. And boom. So now let's take a look at that at my classroom folder. Enter Python, and there I've got a bunch of files that I've got 100 files there. Yep, and it's not really that much. It's, I mean, these are kilobytes of data, so it's not really actually, it's less than a megabyte, but it kind of gives you the idea, right? And well, yeah, well, let's now talk about like something like Zepto or one of those other CryptoLocker ransomwares, right? What it does is that it reads, it takes the old file, reads it, throws it into an encryption algorithm, right? Something that you would normally use to keep like the government from spying on your file or a business from spying on a file. Encrypts it with a key that only the hacker knows. Deletes the old file, replaces it with the encrypted file, and says, "Hey, you want it? You better send me some magic internet money in order to get me your decryption file."
The Nigerian prince guy?
Not the Nigerian prince guy. Those guys are a different class of criminal. These are the ones that are so Nigerian 419 scammers, as it's called, because it's named after the Nigerian Penal Code. Yeah, it's phishing essentially. They send out emails to people saying those are a different type of, those are more scammers than hackers, and they send out messages to people saying that hey, you know, I have a lot of money and I need help laundering it, and you can take a cut essentially. Or I need to get this money out of thing, and it's named after like one of the early common iterations of it, where the guy claimed to be a Nigerian prince, which is hilarious because Nigeria does not have a monarchy. But now, yeah, so another common, so there's more sophisticated ones of these which used to go around, but now people are so involved with spam these days. One of my personal favorites was like the stock genius one, where the guy would say this stock is going to go. He'd say this stock is. He'd send you an email saying on the Magic Stock Wizard this is going to go up. This stock is going to go up. Then he'd send you another email saying this stock is going to go down. This stock is going to go up. Right, 3 days in a row, and he gets it right every single day. Okay. And now on the 4th day, he basically sends you, so if you want to learn how I'm doing this, send me money, right? And the trick was that you just send him his money and he never gives you anything, because what it is that he didn't send it to you. He sent it to a lot of people, and half the people he said this stock is going to go up. Half the people said this stock is going to go down. And then he did that for the next day, and then for the next day. And so he just simply trimmed it down to the 1/8, well, essentially let's call it the 1/8 of the people that he got right. And now they're convinced that if they were reading, they're convinced he's a magic money man, which might be only 1 or 2 people, but that's all he needs. And again, that was just a simple script on his part. Once he has plenty of email addresses, it takes nothing on his thing. So as you can see here, hacking, computer code can be used very much for evil. Do not do that. If I find that out, and I do occasionally check, I will basically go through whatever hoops I can to basically like see what we can do to revoke a degree, that kind of stuff. We warn people that when it's the whole with great power comes with great responsibility. If you would love to do this stuff to people, there's a way to get into that, and that's called white hat hacking and pen testing, exactly. And that's the kind of basically where you get hired basically to expose these problems. All right, but let's go ahead and get to this. We want you to, so in your textbook, this is the Mad Libs program at the end of chapter 8. That's what you're going to work on today. And then we're going to get to working on the hurricane tracker. So because that's what we really need to do. Because I feel like we have got more than enough to do those stuff. Then we'll move on to dealing with other kinds of interesting things.